Hey everybody, this is workbook 1D, velocity is a vector. It says Angela and Blake run toward each other from 15 meters away. Let's actually mark on here that this is 0 meters and this is 15 meters. At time t equals 0, Angela runs to the right at 5 meters per second. Let's label that on here. So she's going 5 meters per second to the right, and Blake runs to the left at 3 meters per second, so we'll label that on here. First thing they want you to do is to fill out this table of where they are at every single second. So at 0 seconds, Angela starts here at 0 meters. Since she's going 5 meters each second, after 1 second she'll be at 5 meters, after 2 seconds at 10 meters, and after 3 seconds at 15 meters. Blake starts out here at time 0. He's here at 15 meters. Since he's going this way, after 1 second he'll wind up at 12 meters, and then after 2 seconds he'll be at 9 meters, and after 3 seconds he'll be at 6 meters. They did not ask for a motion map, but I'm going to put one on here quickly because I think it helps you see it and understand it. So Angela begins here at 0 seconds. At 1 second she's at 5 meters, at 2 seconds she's at 10 meters, and at 3 seconds she's at 15 meters. Whereas Blake, he starts out at 15 meters. After 1 second, he is at 12 meters. After 2 seconds, he's at 9 meters. And then after 3 seconds, he is at 6 meters there. So another way, besides the table, besides the motion map, another way we can track this motion here is we can put it on a position versus time graph. So let's put each of their positions on there. At 0 seconds, Angela was at 0 meters. At 1 second, she was at 5 meters. At 2 seconds, at 10 meters. And at 3 seconds, she was at 15 meters. So let's put a nice line of best fit on there. And so there is Angela's motion represented on a position versus time graph. Now let's do Blake. At 0 seconds, Blake was here at 15 meters. After 1 second, he moved to 12 meters. After 2 seconds, he was at 9 meters. And after 3 seconds, he was at 6 meters there. So let's give him a line of best fit here. And so we'll do this. And so there is Blake's position versus time graph there. Notice they intersect right here at this point, and we're going to come back to that in just a little bit. Next up, they want us to find the slope of each of these lines here, of both Angela's line and Blake's line. They say pick any 2 points on there. I'm going to pick the first and last points. So this is Angela's final Y position, in other words, her final position. So that would be 15 meters minus, and I'm going to do her initial position, which is 0 meters. Her final time is 3 seconds, and her initial time was 0 seconds. So 15 minus 0 is 15, and 3 minus 0 is 3, and 15 divided by 3 is 5 meters per second. So showing that the slope has to be the velocity that they gave us to begin with. Let's do Blake now. I'm going to do the same thing with Blake. I'm going to take his first and final time. So his final position was actually at 9 meters there. His final position was at 6 meters. His initial position was at 15 meters. His final time was 3 seconds, and his initial time was 0 seconds. So 6 minus 15 is -9, and 3 minus 0 is 3. So -9 divided by 3 is -3 meters per second. So that's the slope of the line. It's also his velocity, which we did know that it had to be from the beginning because they told us. So now let's do a different type of graph here. Let's do a graph that is velocity versus time. So their velocities were constant. So look, how do I know that? Because the velocity is the slope of these lines. And this slope is constant, a constant 5, and this one's a constant -3. So when we go to graph this, Angela's should basically be right along this line. I'm going to turn it sideways for a second to make it easier for me to draw it. So Angela's should be right along that 5 there. Her velocity is a constant 5 meters per second. and Blake's is a constant -3 meters per second. So I'm going to draw it like that. Let's flip it back here again. So that is what their lines should look like on their velocity versus time graph. Finally, on the last part right here, they say Carlos makes the following claim about the intersection point of the two lines on the position versus time graph from part A. The point on the position versus time graph where the two lines cross represents the time when Angela and Blake are at the same position and traveling at the same velocity. The student's claim is partially correct. Fill in the blanks of the following statement using evidence from the graph to correct the student's claim. So he's partially right, partially incorrect. So again, they're looking at this graph right here, and they're focusing on this intersection point right here. So I agree that the position is the same because Angela and Blake do have the same position and if we look on here, their position is right in there between 9 and 10, so let's just call it 9.5, so 9.5 meters. And this occurs at a time of blank seconds. So let's look at this time. This would be 1.8 seconds, and this line right here would be 2 seconds. So right about in between 1.8 and 1.2 in the middle there, let's call it 1.9. So it happens at 1.9 seconds. However, I do not agree that they have the same velocity. That is not true because the slope of one line is 5 meters per second and the slope of the other line is -3 meters per second.